This is Algebra 1, Lesson 15, Surface Area. It's example 15.3 for a right circular cylinder. Example 15.3. A right circular cylinder has a radius of 4 inches and a height of 10 inches, as shown. Find the surface area of the right circular cylinder. Now, when you see this, it really helps if you can visualize this as a three-dimensional thing, something that you're familiar with. So when you see that diagram, what do you think of? Is there something in your home that looks like this? These are the things that I thought of. An oatmeal container, or a can of some food item, or a canned drink. That's what we're talking about for a circular cylinder. And those items would work. So if you think about taking those apart, like for example, if you use a can opener and you cut all the way around and that lid falls down in there, that lid is a circle, isn't it? And on the bottom, you have a circle as well. And if you had something really, really sharp and very strong, and you could cut down through here, so you've got the top off here, and you've got the bottom off here, and you were able to cut this and unroll it. If you rolled that side out, what would it be? It would be a rectangle. So a circular cylinder is made up of two circles for your bases, your top and bottom, and then a long rectangle that will wrap around that circle. And if you wanted to know the dimensions of that rectangle, this edge has to fit perfectly around the circle, which also matches up with this edge perfectly around this same circle. Okay? So that helps you think about it. And you could also think of taking apart an oatmeal container. And maybe that would be a good thing for you to do so that you can be convinced that you can take these things into pieces. So I'm going to delete that to give us some space. And I'm going to go back up here and we're going to look at the problem they gave us. So I've got it marked here. The radius of the top circle is 4, which means the bottom would also be 4. And then the height of it is 10. And these are in inches. Okay, so this is a kind of a small little circular cylinder. And we do need to think about it as pieces. So we're going to think about our circle. And we know that its radius is 4. And we know how to find the area of a circle. It's going to be pi times the radius squared. So the area of that top, we're going to use 3.14 for pi. And the radius is 4. And we're going to have to square it. So the area is going to be, we would have to do the 4 squared first. Okay. And then times 3.14. And when you do that computation out, since this is rounding here, we're estimating, I'm going to put estimated. When you multiply that 3 times 16, that's 48. But if you do the 3.14, you're going to get 50.24. And I know you can do that computation. Now, what are our units? I didn't write the units, but we know that they are inches. So when we multiplied here, that was 4 inches times 4 inches, which ends up giving us square inches. So that's the area of one base, that one circle, right? But how many of those do we have, right? We've got 2 of those. So if we've got 2 of those, we're going to need to double that. So we're going to need to find the area of this one is also going to be 50.24 square inches. So maybe need a little running total over here. We've got this, and we're going to double it. Okay, so we've got, so far, this is our area, and that's just the top and the bottom. So now let's go ahead, and I'm going to move this, since we already have it. Now I'm going to think about, like we said earlier, if we cut the top and the bottom off, and then we made a cut right down through here, and we unrolled it, I'm not going to make it quite that big. If we unrolled it, we're going to have this rectangle. And we said that this edge on the top has to match up perfectly with the distance around the circle. Well, what is the distance around a circle? What is that called? That's circumference. Do you remember us saying that circumference is equal to pi times the diameter? Or we have said circumference is equal to 2 pi times the radius, because 2 radii is the same thing as a diameter. So we can use either of those. I'm going to go ahead and just say, well, if I know that the radius is 4, then I know the diameter is 8. It's going to be double that. So the circumference is going to be equal to 8 times the pi, 3.14. Right? So we're going to have 8 times 3.14. And when I multiply those together, I get 25.12. And what is my unit going to be? Well, this measurement that I had was in inches. Now, it's not square inches because this is actually a linear distance here. It's not an area like we did with the circles. Okay, so now we're not going to add that to this, okay, because this figure up here is area. What we're going to do is we know that that is the measurement of the top of my rectangle. That's this distance right here. I need to find the area of this. I've already got the area of this, and I've got the area of this. Now I need the area of this. So I know that distance across the top, and they've already told me that this distance is 10. So that matches up on my little diagram here as that distance. And we know how to find the area of a rectangle. We multiply length times width. So 10 times the 25.12 is going to give me 251.2, because it's just going to move that decimal one place. So now we know that the area of that side, all of this, not including the top and bottom, is this figure 251.2. So when we add these together, that's going to be our total surface area. 351 68 hundredths. Now, what kind of unit is that going to be? Well, just like when we did the area of the circles, this is inches times inches, so this is square inches. This is your total surface area. Now, I want to talk about one thing that the book points out. When we found the area of the bases, you're good with that. You know how to do that. When we unwrapped that side and pretended that we cut it and rolled it out so that we could look at the rectangle and find its area, this area of this side is called lateral surface area. Okay, that's what that's called. So we're going to do that on these other figures. We're going to look at unwrapping the shape and using that to figure out the area of the entire side. So when they say lateral surface area, they're meaning the area of the side that does not include the bases. Okay? And we'll talk more about that in the next video.